In this segment, we're going to talk about electromagnetic waves emitted by warm objects. So right here, we've got a halogen bulb. Right now, the filament is warm, and so the light bulb is actually glowing.
It's amazing because I don't see that.
You don't see it, but it turns out it's glowing beyond the range of the visible light spectrum. If you bring your hand up next to it, you can actually feel there's radiation coming off the bulb. And mostly what's coming off of here is what's called infrared. It's beyond the visible end of the spectrum. And if I take a picture of it with this camera, and this camera is a full spectrum camera. I got this from the Ghost Hunter store, which is fantastic. Apparently, when you look for ghosts, you look for them in the infrared, not sure why. Anyway, it's a full spectrum camera, and it sees infrared, also sees ultraviolet. And if I snap a photo of this light bulb, you can see it, and you can see the light from it. And what you're seeing is the infrared that it gives off. Your eyes aren't sensitive to it, but the camera is. If I take the light bulb and I increase the temperature of the filament, and you're all going to get one of these, they have a dimmer switch associated with it. Sheila, go ahead and turn up the temperature of the filament. Oh, turn it down a little bit. And if you turn it down a little bit further down, and right here, if we look at that bulb, what would you say about the color?
I think the color is a little bit red.
A little bit red. Kind of like yellowy, definitely. If you make it even dimmer, distinctly reddish.
Yes.
Distinctly towards the red part of the spectrum. And then if you make it hotter, and what Sheila's doing is she's turning up the current.
The yellow.
It's turning a little bit more yellow. And now it's starting to look a little bit whiter and also brighter. So as the temperature increases, the wavelength of light that it gives off goes more into the visible part of the spectrum. And also the amount of energy given off goes up by quite a bit. So now, definitely, I'm feeling the energy which is coming off the bulb.
Oh yeah, a lot more.
And this is a halogen bulb, and it's glowing because the filament's really, really hot. And as we get it hotter, it gets brighter, but it also gets whiter. And so the wavelength moved from the long wavelength region of the spectrum beyond the visible light into the visible light spectrum, and now it's like solidly in the visible light spectrum. So it's very bright. We can see it really well. But interestingly, the amount of energy that it gives off hasn't changed all that much. Now this bulb over here.
Should I dim that a little?
Let's go ahead and turn that one down.
Let's see.
Otherwise it's going to blind us.
It is.
This one over here, Sheila, tell us what this one is.
This is considered a reptile heater, and so they use it to put in tanks for, I guess, reptiles and amphibians maybe as well. So.
Like what wattage is this bulb?
This is a 60-watt bulb.
It's a 60-watt bulb. So this is a 60-watt bulb, and this is a 60-watt bulb. This one gives off 60 watts of light, including visible light. This one gives off 60 watts of something else.
Thermal energy.
Thermal energy. It's giving off thermal radiation.
Yes.
Thermal radiation is like really long wavelength. The end of the visible light spectrum is about half a micron. The far infrared that we were seeing with this camera is about 1 micron. This wavelength is about 10 microns. So it's significantly longer wavelength. And your eyes can't pick it up.
No, not at all.
But if you put your hand near it, can you feel it?
Yes, I can. Oh, and it feels so nice.
It feels nice.
On a snowy day.
And actually, you can feel the energy that's radiated from that bulb. And it's a 60-watt light bulb, but it's a 60-watt light bulb that gives off energy in the thermal radiation part of the spectrum. And I can see it with this thermal camera. Now, the coolest thing you're going to get in the kit is we have thermal cameras, several of these for your class. And so when you do these demonstrations with thermal radiation, your kids can do these themselves. There's enough that they can work in small groups. Sheila, go ahead and tip that towards this little thermal camera. And then we can see the top of it, and the top of it is glowing very, very brightly. And you can see the energy that it's radiating. And also, if I look at the base, you can see a reflection of the thermal radiation in the shiny base of this unit. Everything that's warm gives off thermal radiation. If I look over here at the halogen bulb that was recently lit up, you can see it's glowing, and it's glowing fairly brightly in the thermal radiation part of the spectrum, and that's because it's warm. If you touch the top of it, you can verify it's toasty.
Oh,
if I touch
sure
my finger
is.
to it, my finger is now toasty as well, because I warmed up that part of my hand. So this shows us anything that's warm gives off this thermal radiation. The camera picks up the thermal radiation. And we want to demonstrate two things with thermal radiation. First off, we want to demonstrate how thermal radiation interacts with matter. And thermal radiation is, think of it like light. This is a 60-watt light bulb that gives off thermal radiation.
Right.
How can we demonstrate that? Everybody in your kit is going to get some pieces of temperature-sensitive paper.
All
and
right.
if you take that bulb,
And I'm going to point it or have it facing
there we
down.
go, facing down. Whoa, whoa. You can see it's making that paper change color, and it's radiant energy from this bulb
And it
shines on the
wasn't-
paper, warms it up.
And it wasn't touching.
Wasn't
Yep.
touching, no contact. The energy went through space, except wait a minute, if I take this piece of glass and I put it here, and now Sheila shines this over here, and let's pull it back just a little bit. There we
Okay.
go. You can see, if you look at the colors on the paper, the glass is actually leaving a shadow. And that's because glass transmits visible light, but it doesn't transmit thermal radiation. Now you can test this because Sheila emits thermal radiation.
Yes.
So I'm going to go ahead and aim the camera at Sheila, and let me go ahead and start recording here. There we go. And so Sheila's transmitting thermal radiation, looking sharp in the thermal image, and actually you have some wet strands of hair, I think. They're a
Oh, I
little
do.
cooler,
Right
which
up.
is awesome, awesome. Your teeth are a little bit cooler. Now I want you to go ahead and take that black plastic
Okay.
garbage bag and put it over your head.
I know what you think of me.
And it turns out this black plastic garbage bag, and everyone's going to get one of these in the kit, they transmit no visible light, but they transmit the thermal radiation. I can see Sheila through the bag. You can see the edges of the bag ever so slightly, but you can see Sheila through the bag, which is fantastic. Now, if you take the bag off, and next take a piece of glass
Oh,
and
thank
put it up.
goodness.
Take that piece of glass and put it up there. What we see is not Sheila. What we see is me. Here I am. And what you're seeing is a reflection of the thermal radiation that I'm emitting. That's what we're seeing in the camera. So you can see me. Interestingly, my glasses appear dark because they don't transmit thermal radiation. Neither does the piece of glass in front of me. So in fact, what you see is a reflection. And Sheila, go ahead and take the piece of glass away. There's Sheila.
There I am.
Bring it back. And there's Brian. There's me reflecting. You can see the camera. Here's the camera in front that's transmitting the thermal radiation. Very, very cool. So we can illustrate some of the principles of thermal radiation that are going to be important for us, namely that it transmits energy from one place to another, and where it's absorbed, it warms things up. The other thing is that there's certain things that emit, that transmit the thermal radiation, like the black plastic garbage bag. Certain things that you might think of as being transparent that are not for thermal radiation, like the glass plate.
And that's what happened here too.
Oh my goodness, indeed. Just so. So that's some of the properties of thermal radiation, and now we want to talk about, in the next segment, we're going to talk about thermal radiation as an energy transfer mechanism.